Hello class, this is a video tutorial on the applications of calculus. In this video we'll be doing a third example of optimization. So let's get straight to it. The cost in dollars per hour of running a boat depends on the speed of the boat in V kilometers per hour. Its cost follows the formula here. Now it's very important that we understand that this is going to be some cost per hour. It's not implied in this formula, but this is going to be per hour. Okay, don't forget that piece of information as we move along. Show that the total cost of a 100-kilometer trip is this expression here. So we need to find, combining this with some other formula or some other expression to come up with this expression here. While it's not too obvious now, right, there's no diagram that we can use, it's actually best to utilize any formula we can think of. In this case, we have speed, in which case we have the speed of V kilometers per hour. So in this case, it's going to be V equals distance over H in hours. Okay, take a look. We're being told in part A that we have a 100-kilometer trip, so D is equal to 100. That's the only piece of information that we have. So it's going to be V is equal to 100 over H. And now take a look. To find the total cost, isn't it, to find the total cost of anything, it's the cost per hour times how many hours you operate. So in this case, we need an expression for H. So we're going to let H become the subject. So it's going to be H over V. Substituting this now, the total cost is equal to the cost times H, in which case the cost is this expression here. Let's make this into blue. And all of this is going to be multiplied by the numbers of hours run. So hours is given as that expression there. So it's 100 divided by V. Expanding this equation, 500 times 100 is 50,000 on V, plus 40 times 100 is 4,000. V times 1 on V, those will cancel. Plus 500 times 100 is 500 V, because that V will cancel with this one. And take a look. That is the expression we were looking for, as it matches what the question was asking of us. Let's move right along. What speed will minimize the total cost of the trip? So we're getting once again to the calculus portion of this of these questions. And whenever we have to maximize or minimize an expression, we take an expression, in which case we need to maximize or minimize the total cost. So let's write this out. T is equal to 50,000. And because I know we're going to be moving into differentiation, I'm going to express this as V to the negative 1 plus 4,000 plus 500 V. Differentiating this, T prime is equal to negative 50,000 V to the power of negative 2 plus, well, 400 will go away, and the differentiation of 500V is 500. Because I know that I will be needing to calculate the the concavity of this, the nature of any points, let's find the second derivative ahead of time. This is going to give us 100,000 v to the power of negative 3. 500 is a constant, it will go away. So our second derivative is going to be 100,000 on v to the power of 3. Oops. There we are. So for this now, we need to find stationary points. So let's find our our first derivative, sorry. So here's my first derivative. T prime is equal to negative 50,000 on v squared plus 500. Let's combine these terms, okay, by multiplying this by v squared on v squared. This will give us negative 50,000 plus 500v squared all over v squared. Let's factor out 500. Yep. So 500 outside of, 500 outside of negative 100 plus v squared all over v squared. If we were to rearrange this, this is actually, let's rearrange this, it's actually v squared minus 100. And that is a difference of 2 squares, so 500 v plus 10 v minus 10 all over v squared. And for this to find a stationary point, we're going to let this equal 0. Okay, for this now, we're going to multiply by v squared. Equals 0, so multiplying by v squared on both sides. And now we're going to divide by 500, leaving us with v plus 10, v minus 10 is equal to 0. We have two solutions, v equals negative 10 and v equals positive 10. Now it's very clear to see that one of these answers is invalid because we have a negative velocity here, which at this stage in mathematics is not possible. So we have a minimum point here, right? But we can just double check this by substituting this into our second derivative. So t double prime of 10 is equal to 100,000 on 10 to the power of 3. Well, that's 10 with 3 zeros, so this will cancel, leaving us with 100. 100 is greater than 0, so that's concave up. Therefore, v equals 10 is a minimum. So the speed that will give a minimal cost to the trip is 10 kilometers per hour. So I hope that gave you an insight into the optimization of problems. Hope to see you in the next video. Best of luck.